Welcome to the deep dive. Today, we're tackling something really vital if you're prepping for the A-Level Computer Science 9618 Paper 4.
That practical exam, right? The one coming up in June 2025.
Exactly. And it feels different, doesn't it? It's not just theory.
No, absolutely.
Yeah.
This is where you had to show your coding skills live, basically, in a time setting.
That's the core of it. So our goal in this deep dive is to, unpack Paper 4 completely, look at the structure.
See if there are any patterns, maybe, what to expect.
Yeah, exactly. And strategies, definitely need strategies for the different question types.
Plus those crucial little tips that make a difference. We want you feeling confident, ready to, show what you can do.
And we've based this on the official Cambridge materials, examiner reports, expert insights, all geared towards this specific June 2025 paper.
That's right. Focused intel.
Okay, let's get into it. The exam format first. What are we actually looking at on the day?
All right. So it's paper 4. The code is 961804. It's 2 hours and 30 minutes long on screen.
On screen, okay.
Yeah, and it's worth 75 marks. You'll be coding in console mode, no fancy GUIs.
Right, just the text interface.
Exactly.
Yeah.
And you'll use a high-level language, which for, almost everyone means Python these days.
Python, yeah. Makes sense. And what's the main skill they're testing? What's the objective?
It boils down to AO3. That's Assessment Objective 3.
AO3.
Which is all about your ability to design solutions, actually code them up, and then test them properly.
Design, code, test, the whole cycle.
Yeah.
Okay. And the questions themselves, what kind of things pop up?
It's usually a mix.
Yeah.
You might get a question where you have to write a whole program from scratch.
Right. Blank page scenario.
Or they could give you some code and say, okay, modify this or add this new feature.
The modification task.
Very common. Then there's interpreting pseudocode, translating that into working Python.
Yeah, that's a big one.
Definitely. And trace tables, too. So you can follow the logic step by step.
Trace tables. Always sound simple, but need real care. We should definitely talk strategies for those.
For sure. But before strategies, something absolutely critical.
Yeah.
The evidence document.
Yes. Let's hammer this home. Why is it so vital?
It's simple.
Okay.
Everything you want, marked your code, screenshots of output, any written explanations, everything has to go into that document, usually a Word file or maybe a PDF.
And if it's not in there?
It gets 0 marks.
Yeah.
Doesn't matter if your code is perfect on the screen. If it's not copied into that evidence document, the examiner can't credit it. It's like you didn't do it.
Wow. Okay. Message received. Anything else about managing this document?
Yeah, 2 key things.
Yeah.
First, put your name and candidate details on it right away. Make sure they're clear.
Good point.
Second, save it. Save it all the time, like every 5 minutes, seriously. Or even more if you've just pasted something important.
Just constantly hitting Ctrl+S.
Exactly. Imagine losing half an hour's work because the power flickers or the software crashes. Devastating. Frequent saving is your safety net.
Okay, solid advice. So, document is king. Save often. Let's move to strategies now. Pseudocode interpretation you mentioned, it's common. How do you tackle that effectively?
Okay, pseudocode. First step is methodical translation. Go line by line from the pseudocode to Python. Pay attention to the control structures loops, if statements. How do they map?
Right, the syntax differences.
Yeah, and a big one, indexing. Cambridge pseudocode often uses one-based indexing for arrays. Element 1 is at index 1.
But Python starts at 0.
Exactly. So you need to adjust that logic. If the pseudocode says ARAY1, in Python that's likely -0. You have to be consistent with that shift.
That's a classic trip hazard. What else helps?
Before coding, try paraphrasing. Just put the pseudocode's logic into simple English in your head. Okay, this loop goes through the list, adds up the numbers. It helps confirm you understand what it's meant to do.
Like a mental check.
Precisely. And hand tracing is powerful too. Take a small example input, walk through the pseudocode steps manually, see what values change, catches misunderstandings early.
Smart. And what about specific pseudocode words, like EOF?
Good question. Pseudocode has its own keywords. EOF means end of file. You need to know the Python equivalent. Often, reading a file until the end translates to maybe a while, true loop in Python, reading lines, and then you break when the read operation returns nothing, signaling the end.
So knowing those common translations is key.
It is. Understanding the intent behind the pseudocode keyword lets you implement the right Python behavior.
Okay, that makes sense. Now, trace tables. They seem straightforward but can be tricky. What's a systematic approach?
Systematic is the keyword. Start by drawing columns, one for every variable mentioned in the code snippet, and crucially, a column for any output the code produces.
All variables plus output. Got it.
Then you work through the code one line at a time. After each instruction executes, you write down the current value of every variable in the next row of your table. Use the initial values they give you.
Meticulous tracking.
Exactly. Pay close attention inside loops or if statements. Sometimes adding an extra column for, say, the loop counter or the result of a condition, true-false, can help keep things clear.
Good tip. More columns for clarity if needed.
Yeah. And when you think you're done, double check. Go back through your table, comparing each step against the code line. Did that variable really update like that?
Easy to make a small flip.
Very easy. Common mistakes are forgetting initial values or updating the wrong variable or miscalculating something simple under pressure.
Right. And if you're unsure about a step,
Quick mental check. Or even scribble a tiny Python equivalent on scrap paper if allowed, or just simulate that one line in your head with the current values. Verify its effect before committing it to the table.
okay, methodical and double check. Seems like the way to go. What about program modification tasks when they give you code to change?
First rule, understand the existing code before you change anything. Read it through. What does it do overall? What are the key functions or sections? Where did the data flow?
Get the lay of the land first.
Exactly. Then figure out precisely where your changes need to go. Plan it out a little. How will your new code fit in? Will it affect other parts? You don't want to break the original functionality.
Integration is key.
Definitely. And try to match the original style. Use clear names for any new variables or functions you add. If you have time, a quick comment explaining your change can be helpful both for the examiner and for you if you need to look back.
Sensible. And testing.
Crucial after modifications. Test with any given sample data, but also devise your own tests. Think about edge cases, what happens with unusual inputs. Does the original part still work? Does the new part work?
Thorough testing, and then getting it into the evidence doc.
Right. Copy the entire updated code.
Yeah.
Paste it as plain text, never an image. And double, triple check the indentation is preserved. Python lives and dies by indentation.
Plain text, preserve indentation. Got it. Okay, let's talk time. 2.5 hours sounds like a lot, but it can fly by. How do you manage time effectively?
It starts right at the beginning. Quickly scan all the questions. Look at the marks for each part. This gives you a rough idea of weighting.
Allocate time based on marks.
Yeah, a general guide is maybe 1.5 to 2 minutes per mark, but that's flexible. Some questions might take longer, some quicker. Use it as a rough guide.
So don't spend ages on a 2-mark question.
Exactly. Identify the high-value tasks, the ones with lots of marks, or maybe the ones that look complex. Make a mental plan to ensure you allocate enough time for those big hitters.
Tackle big ones first, or build confidence.
Depends on you. If you feel confident with a high-mark question, maybe start there. Or if it looks daunting, maybe do some easier, lower-mark parts first to get some points on the board and build momentum.
And you don't have to do them in order, right?
Correct. You can answer in any order, but, and this is vital, you must paste the code and answers into the correct section of the evidence document. Label everything clearly.
Very important point. Order doesn't matter for solving, but it does for documenting.
Precisely. For coding parts, work incrementally. Build a bit, test it. Build the next bit, test it. Don't try to write the whole thing perfectly in one go.
Break it down.
Yeah. And keep an eye on the clock. If you're really stuck on one problem, say for more than 10 or 15 minutes, with no progress,
Move on.
seriously, consider moving on. Leave a comment in your code if it helps you remember where you were, and come back later if time permits. Getting bogged down kills your overall score.
Better to get partial marks elsewhere.
Definitely. Attempt every part, even if it's just a partial solution or some notes in the evidence doc explaining your approach. Blank answers get 0. Always try to put something down.
Great advice. Don't leave blanks. And what about leaving time specifically for checking at the end?
Yes, absolutely factor that in. Aim for at least 5, maybe 10 minutes at the end purely for review.
What's the focus of that review time?
Primarily the evidence document. Is everything there? All the code snippets, all the required outputs. Are they labeled correctly with question numbers? It's so easy to miss pasting something.
Check for completeness first.
Then, quickly reread the question prompts. Did you actually answer what was asked? Did you follow the output format exactly? Use the specific function names they requested. Those little details matter.
Catching silly mistakes.
Exactly. If you have a couple of extra minutes, maybe run a final test with an edge case or the provided data if you didn't before.
And if you find a mistake right at the end,
Fix it quickly if you can, update the evidence doc. If time is super tight and it's a bug you see that can't fix, maybe add a quick comment in the evidence document saying, I think the error is here, I would fix it by doing X. Might get you method marks.
acknowledging the issue can help. Good tip. Now, staying organized under pressure. Any quick wins?
Keep your digital workspace tidy. Save your program files with the names they tell you to use. Do it as you go.
Don't wait till the end to save with the right name.
No. And close files you aren't working on. Avoid having 10 Python tabs open. Reduces confusion. Keep the evidence document open and accessible.
Makes sense. Okay, let's pivot to common mistakes. What are the big pitfalls students fall into in Paper 4?
Number one, probably, is misreading the question. Sounds basic, but it happens a lot under pressure.
How to avoid it.
Read it carefully. Twice, maybe. Highlight keywords, action verbs, specific requirements like variable names or output formats. Try putting it in your own words mentally. Like, they want me to read from this file, find the maximum value, and print only that value.
Clarify the goal before starting.
Exactly.
Yeah.
If they ask for an explanation, provide it. Marks are sometimes tied just to explaining your logic.
Okay, what else?
Simple syntax errors, missing colons, wrong indentation, typos. Python is picky. Use the IDE's highlighting. Read the error messages calmly. They usually point you right to the line.
Don't panic at the first error message.
No. Then there are logical errors. Off by one, mistakes and loops, using a variable before it's initialized, getting conditions wrong instead of year, and edge cases forgetting to test with empty input, or 0, or the maximum value.
Thinking about those boundaries.
Crucial, especially with things like file loops or sentinel value loops. Another one. Not validating input when you should.
When is validation expected?
If the question explicitly says so, obviously, but also if the context implies bad data is possible. You might need loops to ensure input is the right type or within a specific range. Try except blocks can be useful here too.
So, anticipate potential bad input.
Yes. And poor testing habits. Don't just write the whole thing and hope it works. Test small parts as you go. Use print statements temporarily to see variable values if you're not comfortable with the debugger.
Debug prints are okay?
Fine for testing, but remember to remove or comment them out before you copy the final code to the evidence document.
Good point. Don't leave debug code in the final submission.
And the big one we keep mentioning, failure to document in the evidence file. If it's not pasted in their code as text, outputs clearly labeled, explanations written, it doesn't count. Paste as you go for each part.
Keep that evidence doc updated constantly.
And finally, just ignoring specific instructions. If they say, call the file task1.py or use a function named calculatorage, do exactly that. Follow the constraints. Easy marks to lose if you don't.
Pay attention to the details in the instructions. Got it. Okay, this is super helpful for the exam itself. Let's shift gears slightly. The final 24 hours. What's the best revision strategy? No cramming, right?
Definitely no cramming new topics. The last day is for consolidation, reinforcing key areas, and building confidence.
What are those key areas based on trends for June 2025?
Focus on topics that frequently appear or require practical application. Things like object-oriented programming concepts, core data structures, stacks, queues, maybe basic linked lists or trees if they're prominent in your recent syllabus focus. Recursion is always good to review. And file handling.
File handling again. It seems really central. What specific file operations?
Know how to open files, read data from them, line by line is common, write data back, and importantly, close them properly. The with open structure in Python is your friend here, handles closing automatically.
With statement, yeah.
Understand how to handle structured data, like reading comma-separated values and using split, perhaps. And try, except for file operations, is vital file, not found errors, permission errors, that sort of thing.
Robust file handling.
Yeah. Maybe do a quick mini exercise. Write a script that reads some lines, does something simple, writes to another file, just to refresh the mechanics.
Good idea. What about procedures and functions? Basics, but important.
Absolutely. Refresh def, parameters, return values, variable scope, local versus global. Know the difference between a procedure, just does something, and a function, returns a value. Practice outlining simple functions mentally.
And parameter passing.
Remember, Python passes arguments by object reference. So if you pass a list to a function and the function modifies that list, the original list outside the function is changed too. Important distinction.
Right, mutable objects. Okay, validation and testing, we touched on it, but for last day revision.
Revisit common validation patterns. The while true, loop with try, except for type checking and a break when valid is a classic. Range checks, if value min and value all max. On testing, recap the types. Normal, boundary, erroneous data. Think about how you test past paper questions.
Data structures, focus areas.
Review arrays list, basic operations, slicing, methods, stacks, LIFO, and queues, FIFO, are very common practical topics. Know how to implement their basic operations, maybe using Python lists or collections.ZAK. Linked lists and binary trees understand the concepts, nodes, pointers, traversal. For paper 4, stacks and queues are probably higher probability for implementation questions.
Focus on stacks and queues. Makes sense. And OOP.
Object-oriented programming, yes, definitely review this. How to write a class, the init constructor, attributes, self.variable, methods, that method self, how to create objects, instances, basic inheritance, class, child, parent, and using clue. Maybe a quick refresher on polymorphism like method overriding.
Sketching out simple classes might help.
Great idea. Defined as simple student class or item class, just to reinforce the syntax and concepts.
Okay. And finally, algorithms. Search, sort, recursion.
For sorting, understand at least one simple one-well bubble sort or insertion sort. Know the logic, maybe the pseudocode, and how to code it. Insertion sort seems moderately likely sometimes.
One solid sort algorithm.
Yeah, searching. Linear search, simple loop, and binary search. For binary search, really understand how the low, high, and mid pointers work and update.
Binary search logic is key.
And recursion. Focus on the base case, what stops it, and the recursive step, calling itself. Examples like factorial or simple tree traversal help. Mentally trace one through. Mastering recursion pays off if it comes up.
Okay, that's a great targeted list for the final review. Now, how should they study effectively in those last 24 hours? Any specific techniques?
Active recall is much better than passive reading. Try explaining a concept out loud or writing down the steps for an algorithm from memory.
Test yourself.
Exactly. Walk through past papers, read the question, outline your solution before looking at the mark scheme. Then compare. See where the marks are awarded. Maybe try coding just one part under timed conditions.
Simulate mini exam conditions.
Yeah. Annotated code reviews can be good too. Take some example code, maybe from past papers or your notes, and add comments explaining what each block does. Helps solidify understanding.
Flashcards or brain dumps.
Can be useful for quick syntax reminders or key definitions you struggle with. But remember, those are study aids, not for taking into the exam.
For personal review only.
Right. And prioritize official guidance from Cambridge, from your teachers. Remember, no internet in the exam, so rely on what you know and any offline IDE help.
And the night before. Morning of.
Evening before. Light recap, then relax, get good sleep. Avoid panicked last-minute cramming or stressful chats. Morning of, maybe a very quick glance, 15-30 minutes at key syntax or your plan. But don't try heavy problem solving. Stay calm.
Rest is as important as revision at that stage. Okay, brilliant. Now, let's talk about using the tools during the exam Python and the IDE like PyCharm or VS Code. How to set them up for success.
Big one. Always open the folder containing your exam files in the IDE, not just individual .py files. File open folder in VS Code or just open in PyCharm.
Why is that important?
It sets the working directory correctly, makes file navigation easier, helps with imports if needed. Double-clicking single files can lead to confusion about where files are being saved or read from.
Open the project folder. Got it. What else?
Check the Python interpreter. Make sure it's Python 3.x, the version you're used to. Check the settings in your IDE.
Right, version of Python.
Remember, console mode only. Practice typing input into the IDE's terminal or console window and seeing the output there. No GUI stuff.
Get comfortable with the console interaction.
Yeah. Adjust font size, theme for comfort, maybe turn on visible white space or indent guides, line numbers, turn off word wrap in VS Code for Code.
Customize for clarity.
And maybe tone down overly aggressive linters if they're just flagging style warnings that distract you. Use auto-completion, but don't rely on it blindly.
Indentation settings.
Crucial for Python. Ensure your IDE is set to use spaces, usually 4, for indentation, consistently. Avoid mixing tabs and spaces leads to tabber.
Consistent spaces for indents.
And do a quick hello world test run at the start.
Okay.
Print test. Maybe name, input, enter name. Just confirm input output works as expected and you know where to copy output from.
Quick environment check. Good call. How about managing the files themselves during the exam?
Use the file names they specify. Save them directly into that project folder you opened. Save often. Ctrl+S is your best friend.
Save.
If they provide starting code or data files, Look at them early on. Understand the format. Don't rename or move those provided files.
Leave provided files alone.
And when opening files in your code, use relative paths, just the file name, like open data.txt, or assume it's in the same folder. Avoid full paths like C user's your name.
Relative paths. Okay. Running and debugging.
Run frequently. After each small logical piece of code, learn the keyboard shortcut for running in your IDE, like F5 and VS Code, Shift plus F10 in PyCharm usually.
Shortcuts save time.
If you hit a tricky bug, use the debugger if you're comfortable. Set breakpoints. Click next to the line number usually. Start debugging. Step through F10, F11 in VS Code, step buttons in PyCharm. Watch variables change. It's powerful.
Debugger for tough issues.
Watch out for infinite loops. If your program runs forever, use the stop button. Check your loop conditions carefully.
And if debugging gets too hard?
Don't be afraid to simplify. If your clever algorithm is impossible to debug under pressure, maybe fall back to a simpler, brute force solution that you know you can get working. Some marks are better than none.
Practical approach. Any specific IDE features to mention? VS Code.
VS Code with a Python extension gives you IntelliSense, smart code completion, linting, highlights potential errors, snippets for common code blocks, maybe quick fixes, useful stuff. PyCharm has great autocomplete, CL plus space often helps. Inspections, underlines errors warnings, a strong debugger, find in files is very useful, and the error traceback in the console is usually very clear.
Use the IDE tools effectively. And saving again.
Yes, CL plus S constantly on code files and the evidence document. Maybe paste code into the evidence doc after each part is done. Acts as a backup too.
Good backup strategy. What if a question needs multiple files or modules?
Make sure all .py files are in the same project folder. Use standard import statements, like import my module or from my module import specific function. Test the interaction, and paste all relevant code into the evidence doc.
Okay. And the no internet rule.
Crucial reminder, no Google, no Stack Overflow. Rely on your knowledge. Maybe the IDE's built-in help if it has offline capabilities you're familiar with. Quick experiments in the Python console or EPL for syntax are okay if you're really stuck and have time, but don't waste ages on it.
Rely on your preparation. Fantastic practical tips for the exam environment. Let's switch to the human element now. Managing stress, staying focused. This is huge for a practical exam.
It really is. Preparation is the best stress reducer. Knowing you've done the work builds confidence. Try some positive visualization beforehand. See yourself succeeding.
And during the exam, if anxiety hits.
Quick techniques help. Deep breathing, inhale for 4, hold for 7, exhale for 8. Ground yourself. Pause. Look away from the screen for a second. Positive self-talk. Okay, I know this. I can figure it out. Start with an easier part if the first one feels overwhelming.
Don't get stuck in a negative spiral.
Exactly. If one question is tough, skip it for now, come back later. It doesn't define the whole exam. Try to block out distractions. Focus on your screen. Earplugs might help if allowed, and you find them useful.
Okay, mental resilience. What about staying physically alert for 2.5 hours?
Sleep is number one. 7-8 hours the night before. Have a decent morning routine. Don't rush. Stay hydrated. Water is good.
Caffeine.
Be careful. If you normally have coffee, fine. Have your usual amount. Don't suddenly down energy drinks if you're not used to them. And caffeine doesn't replace sleep.
Sensible advice. Any tips during the exam itself?
Brief eye breaks, look away from the screen. Gentle stretches in your seat. If you hit a wall, maybe switching tasks briefly can reset your focus. Watch your posture. Sitting slumped makes you tired.
Good posture helps focus. Interesting. Nutrition. What to eat before?
Balanced meal. Protein, complex carbs for sustained energy. Eggs on toast, maybe chicken sandwich. Avoid heavy, greasy stuff or loads of sugar leads to energy crashes. Don't skip meals.
Light snack beforehand.
Maybe a banana or some nuts 30 minutes before, if you need it and it's allowed. Stick to familiar foods. Exam day isn't the time to experiment.
Balance steady with rest in the final day.
Yes. Do something relaxing the evening before. Avoid frantic last-minute chats that just increase anxiety. Light exercise can help too, maybe the day before or morning of. And basic logistics, use the bathroom right before you go in.
All good practical advice. What about handling unexpected problems during the exam? Technical glitches.
If the computer freezes or IDE crashes, tell the invigilator immediately. Stay calm. Hopefully you've been saving often, so you won't lose much. Focus on recreating what you lost if necessary.
Stay calm, report it. What if the code just won't run or gives wrong answers?
Read the error message carefully. It often tells you the line and type of error. If it runs but is wrong, use debugging print statements. The debugger, simplify the input.
And if a complex solution fails,
Consider a simpler fallback. Get something working. Remember, method marks a clear approach, even if flawed, can earn credit.
mind blanks, forgetting syntax.
Use the IDE's hints or autocomplete. Think, is there another way to do this? Quick test in a new file if desperate and time allows, but brief, or just relax, breathe, move to another part and come back.
Environment surprises, unexpectedly noisy.
Try to maintain focus. Adapt. If the questions seem unusual, break them down. Apply the fundamentals you know.
And recovering after fixing a bug.
Acknowledge the fix mentally, then move on. Don't dwell on the time lost, focus on the time remaining.
Positive forward momentum. Okay, final thoughts on exam day logistics and health.
Arrive early. Get settled without rushing. Have your ID, any stationery needed. Water if allowed. Dress in layers for temperature changes.
Listen to the invigilator.
Absolutely. Pay close attention to their instructions about saving, submitting work at the end. Ask if anything isn't clear before you start.
And mindset.
Stay positive. Nerves are normal, but manage them. Trust your preparation. You've put the work in.
This has been incredibly comprehensive, a real deep dive into navigating paper 4 successfully. It's clear it's about skill, strategy, and staying calm.
Absolutely. Paper 4 is your chance to really show off your practical coding and problem-solving skills. It's challenging, but very achievable with the right approach.
So our message to you listeners is, go into that exam with a clear plan, stay composed, and trust your abilities.
Exactly. We wish you all the very best. Go code your victory.
And remember, for more great A-level computer science resources, including Zafar Ali Khan or ZAK's excellent YouTube channel, check out www.caswithzak.com.
And if you have more questions or need some support, you can always reach out to AskZ. The WhatsApp number is +923 3628 10241, or use the AskZ chatbot at bit.ly AskZ chatbot.
Remember that feeling of being prepared. That's your power. Combine it with a confident mindset, and you're well on your way to success. You can do this.